Hello, everybody. Hope you're having a good weekend. We're going to do a little bit of a digital atmosphere special here this evening. I don't have a typical time lapse like we usually see. I had some computer difficulties here. The rendering was going to take about 45 minutes and we just ran over. So those animations, they do take a lot of time to prepare. All right, so let's head into, I guess we'll start with a little bit of digital atmosphere. And I'm going to take you back to the 1990s and let you see how it all started with digital atmosphere. Actually, with weather graphics.
Well, anyway, weather graphics really helps as far as being able to see the actual data out in the field. You know, there's one thing about going out there and looking visually, but another thing going out there and actually being able to dial in and get some data and do an analysis either by hand or, in this case, if you don't have time, allow the computer to do a rough analysis, and instead have a almost mesoscale analysis there right out in the field. It's really neat if you're out there and you can actually see visually stuff like the triple point. Sometimes you can actually see the towers going up on the dry line, and the moist tongue, real narrow moist tongue feeding into to the north and back to the northwest as it wraps around the surface slope. Be able to actually see that portrayed out on the map.
We're on Highway 287 right now. We've just got the latest hourly observations at noon, and let me show you this. We just did a surface plot of moisture convergence. You can see that there's a bullseye around Childress, Texas, a bullseye right there. This is the latest hourlies.
To the watch area. Persons in these areas should be on the lookout for threatening weather conditions and listen for later statements and possible warnings. Once again, the National Weather Service has issued a tornado watch effective
Yeah, so as you can see, this software was very common way back in the 90s, and it still continued to be used even now. The internet has made things a lot more convenient, but it also limits your ability to customize charts, and it's very difficult to find current surface plots outside the U.S. Now let me show you the actual program. This is kind of interesting. Let me go back to some of my other directories here. I don't have this too well prepared, but this is what digital atmosphere looked like from 1993. This is an example of the directory here, and if I try to run that right now, I mean, I would love to run this, but you can see it gives me this error here. It's too old for the 64-bit version of Windows. So I guess this is just kind of a relic of years gone by there. But the files, you know, they're sometimes interesting to look at. You can see the old, some of the old documentation there. So yeah, it's hard to believe that some of these components are almost 25 years old. So there's one of the README files there. Okay, let me get my preview window fixed. Okay, there we go. And we'll run it forward. Digital atmosphere was created in Korea, believe it or not, when I was over there back in the 90s. And during my time off, I would program digital atmosphere, and the program looks like this when you're in the compiler. This is Delphi 5 here. So this is the main unit right here. And you can see some of the unit declarations there, and then different parts of the program. They do different things there. So for example, like I've got this one here, like launches a new window and defines how big it's going to be, and then it saves it to the hard drive. And altogether, I don't know if I have the statistics here. Let me check. Information. Yeah, you can see how big the program is, 229,000 lines. This is a huge program, and this is part of the reason why sometimes the updates take a while to come out, because there's so much code to maintain. And the units look like this. These are all the different units used in digital atmosphere, and these all control different functions of the program. So you can see there's probably about 25 to 30 units in there. So one of the ones I would use for importing like METAR data would look like this. You can see all the different data types in here, and if I go to parse METAR, this shows you how it goes about trying to take the data apart. So it looks for all the different cloud elements here, broken, overcast, vertical visibility, and so on, and it does string handling stuff. So very sophisticated there, and that's the way it takes the data and displays it. And that's actually the purpose of the program. Let me take you into that. I'm going to run this in the compiler itself. I think it's already running here. So this is what it does here. It plots maps anywhere in the world, both surface and upper air plots. And we can use this to find fronts and identify different air masses. We can track weather systems, upper level disturbances, and all that great stuff there. So, I still use this all the time because it's also got the capability to prepare publication quality graphics. I can scale the maps up to like 8,000 by 8,000 with large fonts, so they don't look all like bitmapped and everything like that. And also it has the capability to use a font created in 1968. And I converted all this from Fortran code. And let's see, let me set this up for you guys, and I'll show you how that works. What I do is I change the font mode, and then I plot it, and there you go. This is the font that was used on the old National Meteorological Center computers. And I'm not sure what type they were. I think they might have been old IBMs. So these are probably some of the oldest fonts there are, almost 50 years old there. But they're kind of neat because they're very legible. They're very high contrast. And I like the cloud symbols. They come out a lot better than true type graphics. See right here in Mexico right here, you can see the cumulonimbus symbol there. That's kind of like a developing cumulonimbus symbol there. And here we've got some cirrus invading the sky, I think that is. It's been a while since I've done these codes. And then over here, that's stratocumulus. So a lot of these symbols come out really well because they're purpose built. Okay, I'm going to take it back to the true type fonts, and we'll plot the map again like that. So, like I said, this is used for finding air masses and looking for fronts, and it's very versatile. And I can also plot pressure lines. So isobars, there you go. Pretty easy to do right there. And then if you want to, you can draw fronts. There's the capability to do that. course, it helps if we erase the old file. So there you go. A little bit of a front handling ability there. So essentially what this does is it goes out and fetches data from different sources. That's kind of like half of what it does there. So there's a menu option. Let me see if I can get this all in the window here. And for those of you joining or not familiar with this program, this is actually a program that I've written, and you can see my name right there. This is a program that I've maintained for about the past 20 years here. Now, like I said, what it does is it goes out and gets data. There's this data handling thing here, retrieve data, and that goes out to the internet. It gets data from different sources. So the most basic source you can get is METAR. We can get that from the College of DuPage server, and you just go to retrieve. Or if you want a different hour, if you want to go back and look at yesterday's data, that's another powerful thing there. You can't really do that on the internet. Go back and look at previous charts. Everything is real time on the internet, and old data is kind of tossed away. But if we want to look at yesterday's data, that's not a problem. You just type in the date, and depending on the server, that'll go back about a week there. So you go to retrieve, and it'll retrieve the data, and you can see it coming in there. And then what it does at that point is it processes the data. So it looks like that's done already. And the actual data itself looks like this right here. Let me see if I can enlarge that a little bit. There you go. So those are the processed surface observations from about 20 minutes ago. So you can see all the different reports. This is basically how those maps that you saw were constructed. So let me give you an example. Yeah, we'll try Cleveland right here. That's Cleveland, Ohio, taken at 0051 Zulu, which is 50. It's 8:51 Eastern. Winds out of 150 at 6 knots, 10 miles visibility, 10,000 bases of the clouds at 10,000 scattered, so basically half or less sky cover. And then broken, 14,000, so the total cover of the clouds below plus that layer is over half of the sky, but not overcast. And that base is at 14,000, and there's another layer there at 25,000. Temperature 20 degrees, that's going to be 68 Fahrenheit. Dew point 12, which is 54. And then altimeter 3003. And then you can see the remark shows it's shows the type of ASOS station it is. Sea level pressure 1016.6. And then it gives you the temperature data with more precise units. So it's showing 20.0 and 12.2 for the dew point. And you can add other data in there. In the old days, it was very common to transmit remarks when there was a human there. And a lot of times they would transmit funny remarks, and maybe I can show you an example of that. Let me see if I can get to my website that has funny remarks. Give me just a second here. And in the meantime, I'm going to take a look and check on everybody and make sure that the audio is going good here. Okay, let's see here. Yeah, here we go. Sorry that took a while. I don't like keeping you guys waiting on stuff like this. But, yeah, I'm just waiting for it. There it goes. Okay, so yeah. Moose on runway, coyote howling, dog killing rat, polar bears along runway. And there's all these other remarks here. Huge mother towering cumulus. For those who are concerned, the sun is still up there. And there's some more right there. And, you're welcome to look at the rebroadcast and see some of these, or you can email me and I'll give you the link so you can read this stuff. And this is only from the 70s, and I'm going to try to fish out some of the funny remarks from the 80s. The way I found these is I put together like a little dictionary of words, and I searched all of the observations from Global Surface Archives. And that's another program you can, another package you can get. Give me just a second here. Yeah, this is a program that's available, Global Surface Archives. That's on my website at weathergraphics.com, and you can get basically about a quarter terabyte of observations going back to 1930. And it's got all the remarks there and stuff like that. And you can plot surface charts, kind of like what you see there in digital atmosphere, and plot up maps of old situations. So if you want to see like the Edmund Fitzgerald storm, that's pretty easy to do. In fact, I don't know, why don't we do that real quick? Some of you may be familiar with that Gordon Lightfoot song that kind of made the sinking famous. So the first thing that we've got to do is find out exactly what date that happened. This will take just a second here. Edmund. Okay, that was in 1975 on November 10th. And let me see if I can get a time on that. Let's see. I believe that might have been towards dusk when that happened. I don't know if anybody knows, but you're welcome to mention in chat if you knew when that ship sank. But, yeah, let me go ahead and bring the data in. Okay, so there we go. And I'm going to bring this in through my network. 1975, November 10th. And I'm going to take a look at chat and see if anybody knew the time. Dusk? Okay. Yeah, thanks, Sue. So I'm going to go ahead and use the 18... No, I'm going to use the 21Z data. That's going to be getting kind of close to dusk there. So... Okay, let's see here. Oh, yeah. So this is kind of how I bring down observations from previous time. This is basically a data that's a directory that's holding Global Surface Archives. So if you want to look at the data from 1975 there, There you go. And it's been converted over to METAR, since that makes that makes the data more compatible with today's viewers. Back in the old days, they used aviation SA observations, and it was a slightly different format there. Anyway, Duluth. There's the Duluth observation right here. So winds out of the west, 18 gusting to 27, a little bit gusty there. But the Edmund Fitzgerald was a lot further east on the lake, so we can pull up the Marquette. Okay, that's not in there. Sault Ste. Marie, I think that might be in there. But, okay, let's see. I'm not too sure which stations we're operating, but let's bring that into digital atmosphere. Okay, so the way we handle that in digital atmosphere is we go to import specific file, and then we get this file pop up. Okay, so I'm just going to find the correct file. Temp 78, and there's the file containing the Edmund Fitzgerald storm. So let's plot it. Okay, let me get this recentered. Okay, let's see here. I think the storm might have passed already, because I can see it's already up in Ontario there. Let me give you the isobars on that. What I do is I go to analysis and then pressure and then sea level pressure. And so we've got the storm all the way up in Ontario already. And I'm going to bring in the 18Z data. That might be a little bit closer to when the ship sank, I think. I'm not too sure. Sue, you might be right about it sinking around dusk. But I could have sworn that the low was a little bit closer to Lake Superior when this happened. So let me bring in that data. I'm going to look at the 18Z data 3 hours earlier. I had no idea we would be looking at the Edmund Fitzgerald storm today. Anyway, there it is. And the origin of this low was way back over Kansas, and it tracked northeastward, and it intensified rapidly over the relatively warm lake waters there. So you can see the very strong winds providing a very long fetch across Lake Superior, and the ship sank right around in this area here, kind of in the eastern part of the lake. And it was the very intense winds, and you can see all the gusts up there to 30 knots. And over the lake where you have less friction, you're going to have even stronger winds. It would really be interesting to kind of import this data into the WRF model and see exactly what was going on the lake there. Okay, let me take a look at the chat there and see. Okay, 7 p.m. from Jeff Lockwood, 0Z. At 7 p.m., the main hatchway gave in. Okay, so let's bounce back to 0Z. Actually, I don't even have it in there. So we'll just bring that in. That's going to be on the 11th at 0Z, since we advance into the next UTC calendar day. So import specific file. And wow, look at those winds there. 56 knot gusts there at Sault Ste. Marie. Let me see if I can bring up a little bit more data. I'm going to bring up the crowding. Yeah, gust 18 there at Marquette. Wow, 56 knots there. That's going to be about 63 to 64 miles an hour right there in that area. So let me give you the isobars. So there you go, the main low way up there over Ontario, and the ship sank in this northwesterly fetch here in an area of cold air advection back in this region here. Now you can see that the isobars, they're kind of messy, and that's because we're using a very coarse analysis algorithm. Let me fix a couple of deficiencies in the data here. I think there's a altimeter setting or pressure that might be too high. So yeah, this is another thing you can do, is you can fix deficient data. There it is. That's the bad pressure data that's causing this high. Okay. That looks good. 1008, 1009. Everything in here should be between 1,000 and... Okay, now you're going to see that high pressure go away here. So that's another advantage. You can fix problems in the data, and you can't do that with online sources. Okay, so you can see that there's a little bit of coarseness to the field here. So the way we can fix that is go into the analysis program, the analysis controls, and we can change the analysis type, and we're using the very most basic nearest neighbor. So what that means is I'm going to show you the analysis grid. There you go. At each of these vector points, that's where an analysis grid point is located. And so what the program is doing is it's going to each spot, looking at all the data around it, and just trying to find the closest station. So right here in Lake Huron, it's obviously going to grab Sault Ste. Marie and assign that value to that grid point right there. At this grid point over here, it's probably going to grab this one over here. At this grid point, it's going to grab that one. And then it just kind of goes systematically through all the grids, and maybe does one little smoothing pass where it takes an average of all the points around it and gives itself a little bit of weighting, and that smooths the data a little bit. Now, there are more sophisticated analysis algorithms that you can use. So you have that functionality there in digital atmosphere, and there's four main types here. There's weighted, and that's the one where it assigns more weight to the center point, and you can kind of change some of the parameters with that. And there's also Barnes and Cressman, and these are the more complicated methods. And I'm going to use Cressman here. The way this works is it goes through the data, kind of like what I was showing you, and it uses a very large radius, and it takes like an average of all that data. And then it goes through the data again with a smaller radius, and it takes that value. Then it goes to a smaller radius and goes progressively further down. And if it finds a station close by, it gives that higher weight. So this makes it very useful out over the oceans where you have very limited data. You tend to get a more realistic field there. So let's do a sea level pressure using Cressman. And it's going to take a little while. So you can see over here it's converging the fields. You can see the radius going down there. And there you go. It looks a little bit better there. Could probably use a little bit of smoothing. So let's try that. We'll do Cressman one more time. And I tend to prefer this if I'm not in a hurry, because a lot of the data affecting Texas here comes from Mexico. So Mexico, the data tends to be very limited, and if I use nearest neighbor, I'll tend to get unrealistic results out here, and it makes the chart look kind of strange. Okay, so you can see the main low up there over Ontario. And let me plot the potential temperature. This is the temperature reduced to sea level. Now, as a general rule, where the potential temperature crosses the isobars, that's where you have advection taking place. Okay, it looks like we got a little bit of bad data here and there. Let me see if I can fix that real quick. Okay, obviously not 31 there. And let me fix this other bit of data. So this is very handy for those old stations. Humans typing in the observations, and you tend to get a lot of miskeyed information. Okay. I think all the rest is looking pretty good, and just one more bit of bad data. Sometimes these data errors are caused by Fahrenheit being reported where Celsius is expected, and so on. Okay, so again, for those of you joining, we're looking at the Edmund Fitzgerald storm. This was in 1975 on November 10th. Big storm over Lake Superior here, and the sinking was located in that spot right here. Okay, so now I'm going to redo the potential temperature analysis. And we should get a better looking field here. All right, so where you see the crossing of the potential temperature with the isobars, like right in this area here, you can see it forms little boxes like what you see right here in Ontario. This is an area of cold air advection. So very significant cold air advection over Lake Superior. That with the warming from beneath, diabatic warming from lakes and warm ground, that's going to destabilize the atmosphere significantly, and that's going to add to the gust potential. Now, what I'm seeing here also looks like probably a front coming through Michigan, and let me draw that out. I'm going to show you kind of what I'm seeing here. I think this cold front, looking at the potential temperature, you can see lots of cold air advection in this area. I think that cold front is going to run from about here down across Michigan like this. So you see south of that front, we've got southwest winds, temperatures around 50, 45 here. And then north of the front, we've got 30s and low 40s with more of a northwest component. And then I think further north, I think we've got a warm front. Let me see if you can. Yeah, okay. Up here in this area right here, I think there may be a warm front. And we have upper 40s in Quebec. And then north of that, I don't think you can see this. Yeah, let's see. Here we go. Yeah, north of that, IFR conditions, easterly winds, and temperatures in the mid-30s. And then north of that, we're going to have an occluded system. Maybe something like that right there. And the way you handle the occlusions, this is probably a warm occlusion. And the way we figure that out is we look at the air mass on either side of the occluded front. Here in Ontario, 45, that's kind of warm. Up here in Quebec, 30s, it's a little bit cooler in that area. So this boundary is going to act more like a warm front. So with it moving to the northeast, it's advecting a little bit warmer air. So what that means is the occluded front is going to kind of match the pattern of the warm front. If we had a cold occlusion, it would look probably something like this and kind of match the cold front like that. Okay, so different kinds of occlusions, and you can probably read some more about that on the internet. Okay, let me take you back 12 hours and show you the system earlier in the day. You just have to go back and get the earlier data. So what did it look like at 12Z? at about 8 a.m. Eastern Time. Well, let's find out. We can just go into Digital Atmosphere, just go to File, Import Specific File, and then pull down that 12Z data. Okay, so again, we're looking at the Edmund Fitzgerald storm. This is going to be about 12 hours before the sinking. All right, so there's the data. Definitely looks a little bit stormy on the lake. Let me give you the isobars. I'm going to do something a little bit different too. I'm going to change the analysis domain size. This lets you set the number of grid points that make up the map. So I can bring this up to 50 and make the resolution a little bit higher. Okay, so let's do it. Pressure, sea level pressure. So now it's computing. You can see it doing its magic over there on the left. So, yeah, we definitely got a storm right there over Lake Superior, or over the UP of Michigan. Let me fix this data. You can see there's a little bit of bad data in Illinois. Let me just kind of root through that real quick. I'm looking at sea level pressure here. So there's one bit of bad data in there somewhere. I think that's probably it right there. Okay, so let me replot that. And while we're waiting, let me take a look at the chat, see what we got going on. We've got Ron Chalfant with us. Carl Berghoff, evening a lot better. Two shots of gin, which was weird. Yeah, gin is pretty kind of it's got that pretty rancid taste there. I guess it's made with juniper berries, but I kind of like it myself. David Moore, looking for the front this evening, found it on GO 16 infrared, very distinct at the top of the Texas Panhandle. We'll see if we can pull that up later. Sue M, yeah, big front coming through Indiana overnight. We're looking for a front here too in Texas. Winter is almost over, or summer is almost over. David Moore, Bill Johnson, Electric Dog, buckets of rain, northern Illinois. Milwaukee, Bill Johnson reporting 1.61 inches of rain. Carl Berghoff had some Bombay Sapphire, 66, very good. Wow, 66. Ryan Toomeys is at the family farmhouse watching storms blowing through the area. I'm guessing you're in Florida? Looking over Hurricane Irma storm damage. Let me give you the infrared imagery. It's kind of a tradition here. Oh yeah, you can see that front working its way through the Midwest and in through Kansas and Oklahoma. That front is blasting southeastward at a pretty good clip there. Brutal H, hoping to get digital atmosphere as soon as I can afford it. Yeah, there is a coupon. I don't know if you're on the mailing list, but there is a, I'm trying to remember the amount. I think it might be 40% off, but you can email me. That expires at the end of October. So if you want to get digital atmosphere, you can definitely do that. Just contact me and I'll give you the coupon for that. Sven McCall, welcome to the program. Stephen Sawyer, hello. Veo Joe joining us. Veo Joe reporting 79 in central Illinois. Carl Berghoff says he's in Wisconsin. Sven McCall in northern Vermont. And I almost moved up there in Vermont back in 2002, I think. We were, I don't know, we were just looking, we've got some family friends in upstate New York, and we liked Vermont, and we thought about settling just south of Burlington. I forgot the name of the town, but there's like a college there. Very beautiful area. Mike Estwick, 50-mile-an-hour winds in Denver this afternoon. Marshall Reese. Yes, I remember your name from way back. Loved weather graphics. Amazing program for DOS. And yeah, a lot of digital atmosphere, a lot of the source code is basically pulled from weather graphics. So in a way, that old program lives on. The old program was written in it was definitely Pascal. I think it might have been like Object Pascal. Borland Pascal, that's what it was. And it was very easy to import into Delphi 5 and stuff like that. So, yeah, a lot of this code lives on. Veo Joe keeps a PC to run the program. Ryan says storms fired up in Iowa and western Illinois, several supercells. Cthulhu, virtual machine. Yeah, good idea there. Thank you, Cthulhu. Storms all day in northeast Illinois. Let me just kind of browse through this real quick so we can keep things moving. AWIPS 2 is the big kahuna. Yeah, I've been trying to run AWIPS 2, but there's a lot of problems. Like certain maps will not plot, and a lot of model data fields will not plot either, and I had to just end up removing it because it was kind of useless. I was using the Cave version. I don't know if you all are using a different implementation, but the Cave one, it's just a dog. It's just kind of useless. A few fields are kind of nice, but it's just slow, and I gave up on it. And yeah, Carl Burkhoff was talking about the same thing. I mean, wind data, why can't they fix just basic wind plot? Go in there, fix it to where the plots show up, and you're done. Anyway. Yeah, so we've had the same problem. Jeff Krob's Wind Grids, that's another good program. I'm not going to cover that tonight, but in the archives on YouTube, we've got some programs dealing with wind grids, and that's a good way to view model data, and it does cross sections and basically roll your own model data. In SSFC, Kansas City used a control data computer to print those old charts, and they were strung across the walls. Yeah, they're from Marshall Reese. Yeah, we used to have those old fax machines back in the 90s, and sometimes we would shut the weather station down overnight, and the machine would keep running overnight. We'd come back the next morning, and there would be like about 30 or 40 feet of charts all over the floor. So part of the job we would do is we would pull that huge mess up and start tearing it off into individual charts. Lots of fun in a way. And believe it or not, some hobbyists did get those charts at home in the 70s and early 80s because it was very cheap. You basically just had to get, hang on a second. Yeah. There we go. You basically had to get a long line, a dedicated long line to Washington, D.C., and if you did that, you were good to go. You could plug right in, and you could get a surplus facsimile chart and get charts for very cheap. Like, I can't remember how much it was, maybe like $50 a month, maybe $100. But after the Bell breakup in 1982, for some reason, the rates went sky high, and then it ended up costing like $1,000. And I actually checked way back in the day, and yeah, they were quoting me like $1,500 to $2,000. It was really ridiculous. Yeah, Sue M. recommending we do a special on the Edmund Fitzgerald. Yeah, we'll definitely. That's a great idea. If y'all can remind me on November 9th, then I can get that prepared for November 10th, and we'll do that special. I think that's a great idea. And if y'all can pull people in who know a little bit about that situation, then maybe they can join us when we do that special thing on November 10th. Okay, let me just go quickly through the rest of the comments. Tim should retitle this to Edmund Fitzgerald Wreck using digital atmosphere. Yeah, we can use the new tools, definitely. Sven McCall, getting into geophysics, writing a thesis on Lagrangian coherent structures. Excellent. And David Moore says if you check the GO-16 infrared, you can see the cold air mass. Not just the storms, but the air mass itself. Okay, am I looking at GO-16 here? I don't know. What I can do is I can change the enhancement scheme, and we can definitely bring that air mass out a bit. Let me try changing the enhancement curve a little bit here. Yeah, that definitely shows it right there. You can see this all here, this white region here. This is all cold air. This is the ground. It's chilled and radiating very little infrared energy. And you can see it advancing right here in the Oklahoma Panhandle. The cold air just rolling in. And ahead of it, thunderstorms south of Kansas City to the Quad Cities, and more storms in the Chicago area. So why don't we just go ahead and get into the fork. Wow, look at that cold air in Nevada. Good grief. Very cold temperatures on the mountaintops in the Rockies. And this is actually causing cold winds in California. They've been having to deal with very high winds there around the Sacramento area, Northern California, the Bay Area. Lots of smoke problems. And let's see if we can check in on that using the polar orbiter data. Yeah, there's our smoke problem there. Winds out of the northeast, blowing that smoke more towards the area north of San Francisco. But it's good to see that there's no smoke plumes in this area or on these mountains right here. Looks like a few problems in the Sierra Nevadas. But yeah, basically we've just got a cold air mass over Nevada, the Great Basin area, and it's deep enough and dense enough to cross the passes and come into the lower elevations of California there. So it's basically a Santa Ana wind, but I guess it would probably be called more of a phone wind. All right, let's check out the surface map and see what's going on there in California. Let me just go ahead and bring everything up to date. I'm going to have to run digital atmosphere outside of the compiler so I can draw on it. Okay. So let me put this on California, and let's look at things earlier today. I would expect the highest winds to be around maybe 18Z, maybe 17Z. So let me go back and look at the 17Z data. So yeah, in digital atmosphere, it's very easy to go back and look at the previous day's winds. So this is going to be about 8 hours ago. So there it is, the data coming in. You can see it decoding there, and it should be done. All right, looks like a little bit of bad data at this one station, but otherwise, I'm seeing gust 17. It might be helpful to plot a detailed chart for California here. Let me do that. I'm going to go to California. And then after that, we'll move on and look at the rest of the country. Okay, so there's California. And of course, in digital atmosphere, we can plot counties. Very easy to do. You can change the colors and even plot county names. And you can plot highways. So yeah, you can see Highway 5 there. And I'm going to lock that onto the map. Okay, so there we go. There's the plots of wind, and we can see lots of gusts to 25 through the Sacramento area. One station here reporting smoke. Actually, quite a few of them reporting smoke. But anyway, yeah, there's the winds coming in from the north in that region. So let's look at the weather elsewhere around the country. It's probably best to start with a thickness and pressure. This gives us kind of like a top-down approach. We can see that the cold air mass is over the Northwest Territories into the Hudson Bay region. There it is right there. And the frontal zone is right through here. So in through that area, we've got packing of the thickness lines. So pretty obvious, we've got a front, kind of like this. So basically from Kansas City to Amarillo, westward along I-40 to Winslow, Kingman, and then to Bakersfield into California. And then a warm front looks like from Milwaukee to Detroit and then over to Buffalo like this. So south of that, lots of tropical air. We've got a little bit of a southwesterly gradient, bringing moisture northeastward and helping to feed some of these storms here. And then in Florida, we've got more of an easterly component because of the effect of the Bermuda High. I don't know if you can see the Bermuda High. Yeah, there it is, way off to the east. That's kind of a semi-permanent high. And a ridge of that extends into the Carolinas and into Georgia and Alabama. So south of that ridge, we've got easterly winds. And then in Texas, we have the southerly winds feeding into the baroclinic low right there over Iowa. Okay, so pretty cut and dry there. Let's look at things very quickly, region by region. We'll just start with the Pacific Northwest and go through this very quickly. So if you want to see the time, the Zulu time, UTC up there at the top right. So current conditions looking like this. Looks like the flow is kind of like this right here. So probably the center of the cold air mass is over the deserts of Oregon in this region. And you can see at this hour, 42 degrees in that area, 47 in Boise. So overnight, lots of cooling in all of these white color areas. That's freezing. So extensive cold air throughout the Great Basin and Rockies. Okay, for the southwestern U.S., let's check that out. You can see the northerly drainage winds coming in from Northern California right there. Colder temperatures in the high deserts. And, yeah, somewhere in there is the cold front. It's hard to pin that down but looking strictly at this, but probably something like that. It's much easier to find in Nevada. You see right here in Las Vegas, the winds at Las Vegas are a very good indicator of where the front is. Looks like earlier today, north winds very strong. So that's definitely going to put the front a lot further south. Kind of like that probably. And we can see easterly winds there at Edwards and Barstow and Daggett. So I think our front is probably all the way down to the LA area. Possibly down to Phoenix. Maybe something like that. Okay. Then overnight, just freezing temperatures in the high deserts. 35 there at Tonopah. That's cool. Pretty cool. Not super cool, but yeah, 32. Actually, that's getting down there. Lots of cold air. And then for tomorrow, looks like it warms up to 74 at Vegas. Wow, that's a cool afternoon in that area. Okay, let's check things out in the central U.S. Things pretty much dominated by that low pressure there around Omaha moving northeast. So right now things are looking like this. That low pressure moved very quickly into north central Iowa. So it looks like the cold front is right here from around Des Moines to Topeka, down to Wichita, down to Guyman, and then over to Alamosa. And you can see, looks like a outflow boundary out ahead of it. See that right there? So the storms are not really forming along the actual front. They're forming out a little bit ahead of that. And we've got this cold pool comprising the air mass in between. So this is often what they used to call, back in the old days, they used to call this a prefrontal squall line. And they used to think prefrontal squall lines were responsible for most tornadoes. I don't know, there's a little bit of truth in that. You know, certainly when you're out in the warm air, that's definitely a better place to be than along the very strong temperature contrast with the front. So for the next 12 hours, wow, lots of cold air advection. And temperatures coming way down, all the way down to 27 in the Denver area, and freezing all the way down to western Kansas and much of the Dakotas. Let's check it out for Texas tonight. Front on the way in. There it is at this time. Warm tropical flow across Texas. Then overnight, we're going to see that front just barrel southwestward. The NAM putting it through the Dallas area right around 3 in the morning. And then down towards Tyler and Waco around 6 in the morning. And sometimes you can look at this area out ahead of it to see if there's any convection. And I don't think I see any convection. Looks like the wind field is pretty homogeneous, just kind of light and variable southwest. So very strong winds, especially in West Texas. Look at that, sustained 30 knots. So you know that the gusts are going to be way up there near 40 to 45. And there it comes south. And by tomorrow night, it's when we do the webcast, it's going to run from about Birmingham to about Lafayette and then offshore from Texas. Lots of 60s in Texas tomorrow. And then tomorrow night is going to be pretty cold. Temperatures coming down to the lower 50s and 40s across much of Texas. And yeah, I did finally get a sector set up for the Midwest. And that's where the weather is happening. So right now there's that low right there over Iowa. Cold front looking like this. Warm front, that's kind of hard to place. I think I don't know if this is wrong, but I'm going to put it kind of like that, maybe just south of Chicago. I think some of this may be outflow air. But south of that, you can definitely see the tropical air coming north. The triple point located right around Quincy, Illinois. So if we had unstable conditions, this area here would probably be the best zone for severe weather, from about Quincy to about Lincoln and Rockford, where we have this backed wind east of the low. Overnight, cold front makes pretty quick progress. It's going to be coming into western Indiana, through Carbondale. And then for tomorrow, when we do the webcast, it's pretty much going to clear all of the Midwest. And behind it, lots of 50s and 40s. A little bit of a downslope, adiabatic warming effect. The flow not quite from the northwest. So not very cold, but definitely quite a change. Okay, the southeast U.S. sector did not come up for some reason. But we can look at that real quick, just easterly flow there. And looks like maybe a little bit of an easterly wave coming across Florida tomorrow. Maybe during the morning. Yeah, it crosses over Florida sometime, during the morning hours around maybe 10 to 11. And then it looks like it's offshore by the time we do the webcast later tomorrow. And then very quickly for the Northeast, we've got that one viewer there in Vermont. Let's see, what do we have? Just kind of stagnant high pressure across that region. South wind picking up ahead of that next system coming in from the west. So for tomorrow morning, very strong southerly wind. It's going to be a little bit of a warm-up. Warm air advection all through this area. And yeah, there's that front right there. Coming up through Montreal. And then the front approaches. Then by the time we do the webcast tomorrow, it's going to advance very quickly all the way to Toronto. Past Toronto. And wow, look at those winds over Lake Ontario, 40 knots sustained. So gust 50 to 60, you're not going to want to be out on those lakes at all. And front blows through very quickly. And then for tomorrow night, not too cold, just 30s and 40s. But yeah, we're definitely getting into winter here. So there's the temperature anomaly. This kind of shows where things are cold and where things are warm compared to the climate normals. So definitely cold, very cold in Idaho, Nevada, Utah, and very warm in Missouri. Temperatures well above normal in that area. Looks like a bit of a heat wave there in Europe. And temperatures below normal. Uruguay up to Paraguay and Bolivia. Anyway, just something fun to look at there. Okay, so I think we can go ahead and head into the forecast itself. We'll maybe, let's take a look at a sounding. Why don't we do that real quick? It's always good to practice a bit with upper air analysis. Let me figure out where I'm at. Just give me just a second. Okay, we're going to look at the evening soundings. Okay, Dallas, after doing all that analysis, we know that Dallas is in the tropical sector. So we've got a pretty good idea what their sounding is going to look like. And there it is. Looks a little bit like a loaded gun, a little bit of warm air aloft. But lots of warm air from the mid to the upper levels, so that's helping to keep the instability down. So we're not going to see much severe weather with this front. Yeah, parcels looking pretty neutral compared to the environment. So what we're doing is we're comparing a parcel lift from the surface, and we're comparing that to the environment that you see right there. So very little buoyancy. There could be a stray shower here or there along the front. Maybe just a tiny bit of buoyancy. So anyway, that's the way things look right there. Let's go a little bit further north. Let's go back behind the boundary. We'll go to Dodge City. And there we see the northerly winds behind the front. So that right there is the top of the frontal layer. Above that, tropical air. This is the air that used to be there originally. And below that, that's the cold air right there. And you can see the frontal inversion through that layer right there. So that's the frontal zone right there. And below that, lots of air mass modification taking place. Looks like the maximum cold air advection is right in this area, and it's mixing with the warm ground as it moves southward. So we've got this dry adiabatic collapse rate right there in the lowest 4,000 feet of the atmosphere. And then going further north to look at North Platte, that's going to be a lot deeper in the cold air. Looks like the sounding just kind of moves over to the left there. Definite air mass modification taking place. North winds all the way up to about 10 to 12,000 feet, so probably the top of the cold air mass located right there at about 11,000 feet. And let's look at things out in the west. Let's look at Reno. Reno's got a little bit of cold air, topping out at about 10,000 feet there. Above that, a little layer of temperatures in the mid-40s at about 7,000 feet there. And let's look at Oakland. And there we see the north winds there associated with that cold layer coming in from the north. And above that, relatively warm air, lots of dry air in place in the mid and upper levels. Okay, let's head into the forecast. I'm going to pull up the, let's do the European model real quick. Okay, there you go. And before I get into that, let me take a look at the chat, see what we got going on here. I'm probably not going to be able to read all of this. I'm sorry, the chat is very extensive. Sven stumbled upon me in a forum. He was looking for a paper writing on vertically stacked tilted lows and saw I do these live events. Excellent. Good to have you here. And people saw me looking through videos on YouTube. Good to hear. Great webcast tonight. Thank you, Sue. Some people happy with the Midwest sector that we did. Yeah, I'm going to try to work that in from now on. And what Harris, a little discussion there about Harris. Yeah, I remember I used to see their name around a lot about 10 years ago. They did a lot of electronic stuff. Okay, let's head into the European model, see what that's forecasting. So there's the current map. Wow, look at that Pacific air just barging in. So we go from that this morning, 24 hours later, it just rams right over the Rockies. Very fast-moving cold front, and so it's pretty obvious where the origin of this air mass is. And then 24 hours later, tomorrow night into the morning hours, high pressure covering much of Texas, and also all the way down to Mexico. So there's going to be effects in that plateau area in Mexico itself. So temperatures probably running very cold there tomorrow night. And the high pressure dissipates, and you're going to see it merge into the Bermuda High. And then we get cyclogenesis up there in northern Canada, and that's going to keep things kind of mild. We can't get polar air coming southward from Canada with low pressure in place like that. So things are going to be mild for at least a little while. Very strong westerly flow in the high plains. That's going to cause a lot of adiabatic warming. So very warm temperatures for Denver, North Platte, and Rapid City later next week. Then looks like we get another Pacific blast coming in next weekend, 21st and 22nd. Looks very familiar, doesn't it? Very strong pressure gradients. So it looks like the Santa Ana winds may be back again for next weekend. And very dominant high pressure going into the following week on the 24th there, 1034 millibar high across Colorado. And we'll switch over to the GFS. There we go. So overnight, looks like maybe a slight chance of showers, maybe a little bit of forced convection along the front there. Looks like that's going to be back behind the front. So at the very least, probably some clouds behind it. Then overnight into tomorrow for tomorrow night's webcast, that front will kind of start stalling out in the southeast right there. Looks like it barely makes it to Atlanta right there. And going into Monday and Tuesday, finally the high pushes in through the Carolinas, Monday into Tuesday. Southerly flow returns in Texas, so things start warming up. Systems up in Canada, way up there midweek. And then the next big change comes in from the west. In the meantime, we're advecting a lot of tropical air back up into Texas. However, things are coming together there in California. It looks like a potent system moving in. And then for Friday going into Saturday, there it is. We can see the system moving across the Great Basin into the Rockies on Saturday. And that'll emerge out into the plains around Sunday. Looks like the GFS is not going so aggressive with that high pressure area. And I'm not too sure which model has the best track record with that kind of thing. I don't know if it's the European or the GFS, but the European had more of a very large 1040 millibar high across the western U.S. But the general pattern is still kind of the same. We're still going for kind of a large Pacific high moving in. Gulf is going to be shut down once that moves in with that northerly flow. And then here comes the next system for the 26th. This looks even stronger. So I wonder if the European model may end up going even stronger with this one. Things very stormy there in Minnesota for the 26th, 27th. And wow, look at that push of cold air. Very strong. GFS forecasting snow all the way down to Oklahoma City, Wichita, Kansas City, and Des Moines. And that 540 line coming all the way down to Amarillo and almost to Chicago. So this is going to be a very cold air mass if this actually verifies. And wow, look how, if this was winter, we would be looking at highs in the 20s in Texas, probably teens and 20s, and even much colder in Illinois. This is a deep winter type pattern. And things moderate on the 30th and 31st. things will probably be kind of cool across the eastern U.S. for Halloween, and probably above normal in the Rockies for Halloween there. Okay, so that's about all I have for tonight. Let me take one last look at the chat. Let's see here. Mike Bexley got on the mailing list after purchasing some of Tim's books. Yeah, if you guys want to sign up and get announcements on new products, you're going to want to go to weathergraphics.com/contact. There it is, weathergraphics.com/contact. And if you go down here, there's an announcements list. There's one here for all of the products, and there's another one specifically for digital atmosphere. So, yeah, definitely use these because I'm trying to use these lists to send out information when I have something new, so please do that. Okay, so that's about all I have for tonight. Hope you all enjoyed it, and we'll see you tomorrow at the usual time. So take care and have a good rest of the weekend.